Welcome to video clip 6.7, in which we look at consistency of processes and decisions. We have seen in the previous video clips and also in the previous weeks that a business process with decisions can be represented by several models, in particular by a process model that we express as a bpmn process diagram, by a decision requirements model expressed in a DMN decision requirements diagram, and also by a decision logic model, for instance expressed as a DMN decision table. From modeling theory, we know that we can have one original and several models that describe this original. And this is exactly the case here. We have one original, which is the business process with decisions, and we have three models that describe this one original. And we stipulate that these models need to be consistent. There must not be any contradictions between these models. Maybe you remember these models from the kitchen that we used in the first week of our online course, where we had different models that describe one original, which is a kitchen to be built. So we had one engineering model that tells us where the sink is, where the windows are, where the door is, and where the fridge is, and so forth. And on top it exactly says something about the distances and about very technical things like this. We have here on the right-hand side another model of this kitchen, more of a graphical model that allows us to understand how the kitchen would look like once it's built. And here we also see the sink on the right-hand side, and we see the door here, and we see the fridge in this area, and we see the window here. So it turns out that elements need to be consistent with each other, and we have the feeling that these two really refer to the same original, the kitchen to be built. We see here that we have the sink in the engineering model, and we have the sink here. We have the window in the graphical model and the window in the engineering model. The fridge is here, and we have the door here. So that's what we call consistency. Two models have something in common, and there must not be any contradiction. They must be consistent. And now it's clear what we aim at in this video lecture. That is, we want to investigate consistency between the three models that I mentioned up here. So let's start with structural consistency. And the structural consistency involves different things. For instance, decision tasks and decisions, so decision tasks in process models, decisions in decision requirements diagrams. We also look at data aspects, and we also look at organizational aspects. So let's start with decision tasks and decisions. And the consistency property here states that for each decision task in the process model, and here we have one, that is our determine basic credit card eligibility. For each decision task in the process model, there must be a corresponding decision in the decision requirements diagram. So here we have the decision requirements diagram, and this is exactly the same label, so we can conclude that there is a decision in the decision diagram, the decision requirements diagram for a decision task in the process model. If we look at input data, things are a bit more complex. The consistency property here is that input data object in the process model need to match input data in the decision requirements diagram. So the data object, the input data object to the decision is called application information. And here in the DRG we have applicant age and we have applicant employment status. So it's not exactly a one-to-one match in this context. And this is a very typical situation because data is often either not represented in process models or data is represented in a different level of granularity, like we've seen in this example. Application information is more coarse-grained, and the input to the decision, like applicant age, is more fine-grained. The approach that we propose is the following. So we propose to use data models like UML class diagrams to align data objects in processes with decision inputs. And we also need to make sure that all data is available at a point in time when the decision task is enabled. So we have here application information. There can be an UML class diagram that specifies exactly what are the data structure for this application information. There needs to be something like applicant age, so an attribute age of the application information object, for instance, and there needs to be another attribute which says employment status. And then we can refer using the UML class diagram exactly. We can use that structure to link the data actually to the decision. As this discussion shows, the main aspect here is that models facilitate communication. So process and decision models expose the need to align data object with decision input. And this is the most important point here, to use models as vehicle for communication and to make sure that data is aligned. Let's now look at organizational aspects. We've seen in the process modeling using BPMN that we can specify lanes in business processes and assign thereby responsibilities to activities, so persons or roles who are responsible for conducting activities. And we've seen earlier this week that we can also specify organizational aspects in decision models. And these are the basics for our next consistency property, and that's as follows. The resource identified by the lane of a decision task D in a process model matches the resource that is the decision maker of D in the decision model. In DMN, we can also specify a decision owner who can be involved in a possible reviewing activity of that decision as a second point. Now that was a bit abstract, so let's use an example to illustrate these consistency properties in a bit more detail. And here you see a variant of the credit card eligibility process we have been talking about quite a bit earlier this week. We now have two lanes where we have roles claim clerk and claim manager, and still we have the determine basic credit card eligibility decision. Then we have a decision requirements diagram, and as a property or as an element of the decision requirements diagram, we can specify attributes of decisions. And here we have the attribute decision maker and decision owner. Decision maker is the claim clerk. That's exactly the role we have here. And the claim manager is exactly the role here. So thereby we can make sure that organizational aspects are also consistent, so that the decision maker in the decision requirements diagram matches the role that is responsible for performing the decision in the process. So the first part is quite immediate. So the decision maker is quite immediate. What's not so immediate but also quite useful is the decision manager or decision owner. And here we use the decision owner to review the decision, right? So after the decision is taken, the process does not immediately continue, but the claim manager reviews the decision and then either says okay when the claim manager says okay, the process continues, and if the claim manager says not okay, the process goes back and the decision needs to be re-evaluated. Okay, so these were the structural consistency criteria. Let's now turn to behavioral consistency. Here we like to investigate if the decision output is consistent with the process behavior. We specify two quite simple consistency criteria. The first one is called output coverage. Output coverage means is all output of the decision, or can all output of the decision be processed by the business process? So that's a view from the decision to the process. A view from the process to the decision is branch coverage. Looking at the question, each branch in the process is represented by at least one possible output in the decision model. As a remark, we use an example also to illustrate output coverage and branch coverage. And this is a fictional train ticket purchasing scenario that we use here, with quite a complex process and with one decision that we want to go into a bit more detail. Okay, though this example has been inspired by the German train company, Deutsche Bahn, where there are specific discount cards offered called Bahncard. And so once a regular booking is received, this process offers this discount card, this Bahncard, and the client has two options. Either he or she can decline and pay the normal price, or he or she can buy a Bahncard and can use that to get a lower fare. And how much discount this client gets is determined by the manage discount decision task here. And then here in this example we have options 25% or 50% discount, and then the respective activities so that the client gets the discount at the end. We also, of course, have a decision requirements diagram with a decision manage discount. So here we have the structural consistency we can check immediately. We'll also have an input called Bahncard, and also the Bahncard we can check the structural consistency criteria. It's also fulfilled here. And we now look into the details of the logic, of the decision logic, and we'll have it here in the lower right-hand corner. I like to stress that all values are made up. The process is also made up, and also these numbers are made up. They just serve illustration purposes. Okay, so yes, the Bahncard has a type. So the input is Bahncard type and Bahncard points. So clients can own points, and if there are points larger than, or if there are at least 1,000 points, then the discount is even larger. Okay, now let's now look at the consistency criteria. The first one is output coverage, the output coverage criterion. So are all outputs of the decision in a way, or can all outputs of the decision be processed by the process? That's the basic question. We use a slightly modified decision table here. So all outputs of the decision can be processed by the process. So it's a view from the right to the left in this example, so from the decision table to the process. And now in the decision table we can look at the output. Well, the output is 25, 50 and 60. But in the process we just have 25 and 50. So for 60 there is there's no coverage in the process. So the decision could come up with an output value that the process cannot work on, cannot no longer process. So it's clear in this example that the output coverage criterion is actually violated because there's no branch in the process model for the output 60%. Let's now look at the second criterion, which is the branch coverage criterion. Here, each branch in the process model is represented by at least one row in the decision model. So it's basically the view from left to right, from the process model to the decision table. Again, we slightly modified the table to investigate this property. Okay, here we not only change the table, but we also change the process. So here we have the process telling you having alternatives or branches for 25%, for 50%, for 60%. But here in the discount output, we just have alternatives for 25% and for 50%. So also certain branches are not covered, especially the lower branch, the 60% branch is not covered. Therefore also the branch coverage criterion is violated here. Simply because there's no row in the decision table for the branch 60%. This brings us to the end of video clip 6.7, in which we discuss the consistency of processes and decisions. We first looked at structural consistency between activities activities and decisions. We looked at data aspects of data objects and processes and input to data in decision requirements diagrams, but we also looked at organizational aspects, especially at the decision maker attribute of a decision and the respective lane indicating the organizational role responsible for taking the decision. We also took a look at the behavioral consistency, especially by looking at output coverage and branch coverage, where output coverage investigates the way from the decision model to the process model, and branch coverage, the opposite, from the process model to the decision model. This brings us to the summary of week 6, in which we discussed business decision management. I think we've shown quite nicely that DMN provides answers to the questions that we raised in one of the first video clips in these weeks. If you remember, we raised questions like how are decisions actually taken? Which data is being used? Which policies are taken into account? And who is responsible for the decision? And we can use decision requirements diagrams, and we can also use decision tables to answer these questions. So how are decisions taken is basically determined by the decision logic, for instance, by the decision table. Which data are being used? Well, which data are being used is specified by the inputs on the decision requirements level or by the respective column in the decision table. Which policies are taken into account? Well, the policies can be associated also with the decision and the decision requirements diagram, so we can specify the policy. And we also have seen that we can say exactly who is responsible by using the decision maker attribute of the decision. I also like to stress that currently there is massive interest by industry in decision management, especially in DMN, for instance, in the financial sector. Main drivers that we see here is auditing and compliance requirements, which are increasing constantly. And another driver is also the quest for moving processes closer to implementation and thereby help reducing the business IT gap.